Exploring possible hyperparameters without it being an experience of mind-numbing frustration, right here on Machine Learning Basics. Normally in my videos I say, hey, if you find something useful in this video, go ahead and hit the like now button. And I do mean it. It really helps out the show and whatnot. I'm going to be honest with you. You might as well hit like right now because this is probably one of the most practical and useful things that I've produced. And I think people are going to really find this handy. So what I'm doing is exploring possible settings for hyperparameters. So a lot of times when you're setting up your first machine learning experiments and you're trying to figure out, what should my learning rate be? Or how many hidden layers do I need in my network? The answer is, and I'm the same way. Nobody really knows until they try it a couple times. And so you have to go through a bunch of experiments to figure out, okay, maybe, I need more hidden layers in my network or something like that. And so we really need a way to go through and reliably find out what parameters work best for the training that we're doing. Now, previously, we've been going through and we've been doing single runs. And in the last video, I showed you my automation tool to do a batch. This time, I'm going to show you how we use this automation tool to actually go through multiple iterations of configuration to get results. And so the first question is this worth it? Does it actually yield you useful information? And for that, I'm going to say yes. So what I did is I ran an experiment with my existing environment, and I said, I don't know how many hidden layers I really need to be successful. And so I said, I'm going to run a bunch of experiments, and I'm going to run them for 100,000 iterations, which is a significant number. And I'm going to do, I believe, 3 runs of each, right? So that we don't just have a single data point for each configuration. So what you see here is with 2 hidden layers in the network. So we can see hidden units, increment 2. So that's 2, a value of 2 for the part that I can care about, a run 0, 1, and 2. Here's where we ended up. So all 3 of them started, they went up, and then came back down, and then they ended in the 3-ish range. Sub 3 is the value we got for that. So then we notice we have increment 4, so that is 4 hidden layers. And so we put those on the map, and we see that, again, sub 3-ish. So nothing really great going on there. Then we can turn on the 8s, and again, everything is sub 3. All right, so let's turn on the 16s, and then we can say, all right, wait a minute. We have these 2 that are sub 3, but this one's up at 5. That's a very, very different number than these 2. It did really well here. Maybe it just got lucky, but that's interesting to keep in mind for the 16. Let's keep looking. What do we have? 32. Okay, now all of the 32s are way better than the 16s were. Well, we have this one that was with the 16s, but then these 2 were better than 32s were, or sorry, better than the 16s were. So all of a sudden you can see that there is a huge improvement here. So now instead of being sub 4, we have one right at the 4-ish mark and a couple at the 5, 6 mark. So we know that 32 layers seems to be working better than 2 or 8 for sure. Well, and then of course this keeps going. Right now we have 64. And holy cow, we're way higher. In fact, we're going to have to kind of re-baseline our range here because we've gotten so high. So now, we're in the 7s-ish, 6 and 7s-ish. We will say that this one didn't do as well as the other 64s, but by and large, the 64s are even doing better. That's great. So we've definitely noticed an overall improvement in performance based on the number of hidden layers. Let's go ahead and turn on the 128, see what happens. Oh yeah, they did even better. So we're definitely had a case where more hidden layers is helping this algorithm. Now, there's also going to be a maximum level, right? That sooner or later this is going to top out, and adding more hidden units doesn't really help. And that seems to be at about the 128 to 256 range. as soon as we bring those in, we see that we have a lot more going in this particular area. So, but where we ended up here is with, again, 12s and 10s and 8s, and your numbers are going to be different, depending on what your reward functions is. But the point is that compared to our original settings, in the same amount of training time, we're getting scores that are reliably double or triple what we were getting for some of the original execution. So, in this case, I would probably look at all this data and say, the 64s and the 128s, I'm probably going to go with 128. Now, the other concern, though, is we have with those additional hidden layers, right, is the performance going to be less, right? Is it going to take way longer to train? Is that a concern? So we can turn on these low-level, increments so that we can do the comparison of these ones to those ones, and we move it to relative time, and we can see that, no, it doesn't look like it has any impact at all, right? This is all happening at about the 11-minute mark, right? Yeah, 11.5 minutes. And then a couple of these took longer. It might have just been a background process on my computer. Something kicked off, I'm not sure. But it's not a huge performance difference. And those are, yeah, I mean, one of those is the, 2 hidden layer increments anyway. So for this machine, for this problem, for this training, going up to some of these higher level numbers seems to have no downside, certainly has helped training a lot. Now, normally, setting all of that up would be a giant headache, right? You got to figure out, okay, 2, 4, 8, 16, 32, 64, 128, and 256. So we ran 8 experiments, and then I ran each experiment 3 times. That means I have 24 sets of results, and keeping all of those config straight, and which is which, and how do we name everything. Of course, we have automation to help with that. We don't have to do that at all anymore. So we can come down here and we can just look at our Python, and we'll see that there is a config file for 2, 4, 8, 6, 13, 2, 4, 8, 16, 32, 64, 128, and 256. And you'll see that same thing here. So there are YAML files for each of those. And so these YAML files are used, and so you'll see hidden units 2, hidden units 16, and these are already set up and saved. And so if you're like, oh, I just need to go back to that and rerun it, it's saved off to the side, and it will make a backup of your trainer config.yaml, and you can see all of the different backups that it's used here. So it'll make a backup, copy this over to trainer config.yaml, and then run the experiment with that particular configuration for that configuration increment. So it works. It's awesome. It gives you great information. So the question is how do you get it set up? And it's not that bad. So what you do is, again, we have the new GitHub for the automation project, and you'll come down here to the variable config.unity scene, open that up, and again, ignore the camera and the light, come to the training manager. This needs to be set up to your computer's configuration. This is set up for, I run the Python stuff off of my E drive, and then I have different model directories and everything. So you need to change this so that the configuration is appropriate for your computer. On start, it will check TensorBoard and start up TensorBoard, and then once TensorBoard is up and running, it will begin training. If TensorBoard isn't up, it will try to start up TensorBoard again and then begin the training. In the Run Manager, this is going to be very similar to what we saw before. Now we said, let's see here. Our run set name was hidden units, and we'd pause 2 seconds between runs just so that the system has a chance to reinitialize. We have a starting config increment of 32. I think I started it at 2. I think I may have just changed that. And then the max config increment, in this case it says 128. We went to, pardon me, 256 before. Runs per configuration 3. So that means we ran 3 times in each configuration. That way we could get comparative results, because we saw sometimes they did really well, sometimes they did really poorly. So every now and then you just get an outlier, so you want to run it more than once. 3 is a little on the light side. I did that for the demo. You may want to go, I find 5 really gives you a good sense of, you know, do we just have one outlier, or is it really spread between, you know, a bunch of values, something like that. But, you know, 3 works, 5's better, just so long as you want that higher than 1. TensorFlow config, we've already talked about that. Your tensor board manager, we've already seen that. The continue from saved and continue from model, we're not going to get into. And then the run stats, this is where it's going to put the results of the run, so it has it handy. I had to restart my machine. OBS needed to restart, but I can show you what the results screen looked like before I restarted. Ooh, hey. So long as Windows works with me. Here we go. So you can see that there was a whole bunch of, you know, these were the results that came out. So there was 24 results, as we'd expect, right? So 8 different configurations, 3 runs per configuration. So that gets filled up again. For future videos, we'll start going into what you can do with those populated run stats. But for now, it's just nice to know and have those there so that you have pardon me, a collated place to have all that information after you've done a run. All right, so unstart increment, here's where things get really useful. All right, so first of all, for this, we increment double. So we start at 2, we doubled it to 4, we doubled that to 8, 16, and so on down the line. So we didn't want to go through, you know, 2 hidden layers, 3 hidden layers, 4, 5, 6, 7, 8, 9, 10, right? We wanted to have more distance between our configurations. So the idea is you sit down and you map out what are all of the possible, how many possible configurations are there between 2 values? And you say, all right, well, for the hidden layers, you know, in theory, between 2 and 256 are the possible values, and you can only increment by 1. So there are 256 possible configurations if you're exploring that range. Now, we're not going to touch on every one of those possible configurations. We're only going to touch on every value that lands on a power of 2, and we get that by doing this increment double. So on start increment, what it does is this goes into the run manager, and it actually looks at the configuration, and it figures out how many increments there are, where you are in the process, and then it will actually modify and save your config files appropriately for that run, and then it'll begin executing that run. So the config manager, what does that look like? Well, our JSON settings adapter, we didn't use that at all. We said at all times we're just using 20 layers. So that doesn't look a whole lot different than before. But if you look in our trainer config adapter, right, because we saw the JSON earlier, I'm sorry, not the JSON, the YAML file earlier, and we said we had a couple of values in the YAML file, right? The max steps, which in that case was at 100,000, and then we also had the hidden units. So what we have here is we have a start value and an end value. So we're going to say our start value is 2, our end value is 256, and we will go up to our run manager and we'll say we're going to start incrementing at 2, and we're going to go to 256, and then we're going to use this increment double so that it doubles it every time. And then the max steps, we overrode that and we said 100,000. All right. Now, for this video, I'm going to actually do something a little ill-advised, and I'm going to say 2,500, right? That's a super duper short number of steps. And for the run manager, I'm going to do 2 runs per configuration, which again, I don't recommend. We're just doing this for purposes of demoing, and I'm going to say live demo. Okay. And then I'm going to hit play. I already have TensorBoard running, so it's going to notice that TensorBoard is already running, and it's going to just hop right into the training. Right, so now we have our Python environment up, and we have TensorBoard running. It's going to take just a second for the Python to start executing. But once it does, you'll see all the configuration. There it is. And starts up your program, and boom, we see that hidden units is 2. And it looks like, Oh, I have a program running in the background with this animation, and so it's not able to start up BLAS, so it's going to actually error out of these. So it's not going to generate any data, but we will see as it goes through and starts up each of these programs, you'll see our Python, right? Live demo 2.json. Oh, that's the JSON. Let's do, because that's just going to say 20 layers. Live demo increment 2. Here we go. And so you'll see hidden units 2, max steps 2,500. And that's something that we set up. And then live demo increment 8. Sure enough, hidden units 8, max steps 2,500. So it's going to go through and try to do all of those in a row. And again, what's nice is if you're saying, all right, I know my configuration for TensorFlow. I've already figured out what my hyperparameter should be, but maybe I don't know how many layers I should have, or maybe I don't know some of the reward values that I should have for certain actions, and I've parameterized those reward values. You can actually do the same thing in here and tell the system, hey, I want to go from 2 layers to 256 layers, just like we were doing the number of hidden units. So in this case, I'm not going to override the hidden units. I'm gonna stick with 128 because I was really happy with that before. All right, and then you can hit play. And so just like it did it for the hyperparameters, it can also do it for any parameters that you are passing in to your program via the simple key value pair JSON set. So here it is, able to explore hyperparameters and make good use of automation so that you can start making informed quality decisions about how you should configure your machine learning algorithms. So also, just wanted to say a huge thank you to all of my new patrons on patreon.com. I really appreciate you coming in and joining in. I really appreciate the support, and I hope you find this very useful. And again, anybody who is new to these videos, if you find anything useful in here, hit that thumbs up. I certainly hope you found something useful in this. I know that I'm going to be using this a lot so that I can understand what an optimal training configuration is for the projects that I build. All the GitHub and everything is below. Questions and comments can go below. Happy to help as much as I can. So until next time, good luck and happy learning. Take care. Bye-bye.